take a look at how we can implement what we saw on the whiteboard using C++. So the first thing that we want to do is a linear array implementation of queues. So we saw that we enqueue from the rear and we or the back, and we dequeue from the front. The enqueue part is pretty straightforward. Just like increment the back and insert the data in. You just have to make sure that the array is not full. If you want to dequeue, we remove data from the front. So the way we implemented that was just incrementing the front index, right? The downside of that, the disadvantage of that, is that we have waste of memory spaces. One other thing that we could do is just like shifting all the elements one to the left, or like shifting them, moving them down to the list, which is not going to be ideal. Well, it's not actually not a legal move, because it's not going to be big O notation 1. It's going to take us like n moves to do that, right? If we have the whole array full. So this is not accepted. This is a slow process. So what we do is just basically increment the front index. So this is like showing the pseudocode that we just saw for enqueuing. We just check if the array is full. How is the array is full? Like when rear is or the back is equal to size minus 1. If the array is empty, we have to initialize both front and rear to the same index, which is 0. Otherwise, we're just going to be incrementing the rear index, the back index, and then we insert the data that we want to enqueue into the corresponding element of the array. For the dequeue part, we have to make sure that the array is not empty. How can we know if the array is empty? We initialized both front and rear index to number -1. If that's the case, we can't dequeue, so we either return through exception. If front and rear are equal, it means that this is going to be the last element that we have in the queue, and this is like after this the queue is going to become empty, so we have to initialize both front and rear to be -1. Otherwise we're just kind of incrementing the front index. That's it, right? As mentioned, like the downside of that is like we have waste of memory. This shows the C++ implementation of enqueue. So exactly the same thing that we did. We just checked if the queue is full or not. Then we checked if this excuse me, if the queue is empty. So like if this is like the first number that we want to enqueue, we have to change the front. Otherwise we only need to change the rear, right? And then we insert the value that we want to enqueue into the corresponding element of the array. Similarly, this is the implementation of dequeue for a linear array. We have to check if the array is empty or not. If it is empty, it means that both front and rear are going to be -1, or we can just check if front is equal to -1. If that's the case, we can't do anything, like return. Else, we have to check if the number that we want to dequeue is the last number in the queue, the last element of the queue. If that's the case, we have to change the rear as well as the front. So in that case, we make both of them -1 so that we know that the queue is empty. Otherwise, we just need to increment the front. Couple other operations that we can have, like to return the front of the queue, we can just write a function like this, and this basically checks again like if the queue is empty or not. Otherwise it would return the front of the queue. If you want to display all the elements of the queue, you just like have to write a for loop to do so. Again, you have to check if your queue is not empty. This shows like the whole implementation of linear array using C++. So I have a practice question for you guys. Here, like we use the global variables for front and rear, and like all these functions are non-member functions. So what I want you to do is implement this in the class. Like let's call the class Q. We would have two private member variables, as well as the array, and these all become member functions of this class. So try to implement that. And we saw that we have a good trick so that we get rid of that disadvantage of linear array, which was the waste of memory space. So we basically wrap this like array around, like you just like make it a circular array, so that the indexes go from 0 all the way to 7 and then goes back to 0. How could we do that? We use the mod operator, the remainder operator. So if you're just like, this is just a review of like what the mod operator is, and here basically shows that like when we reach the end of the array, we can just like, when we increment this, so here like the size is 8. If you want to go to the next one, we just like say 7 plus 1, which is going to be 8, and mod the size, which is 8, going to go to the 0, right? So this is how we can just wrap around and like go to the beginning of the array, go to the start of the array. It shows like all the like review concepts about the mod operator. Again, like you can see that like how things can go, like how it can just wrap around. And so this is like the pseudocode that we just saw. Like if you want to enqueue, we first like have to make sure that the array is not full. How could we do that? In the linear array implementation, we just like said if rear is equal to size minus 1, equal size minus 1. But we saw that that's not going to work for the circular array. So we have to say that if rear plus 1 mod size is equal to the front. If that's the case, it means that our array is full. So return. Otherwise, you just like have to check if the array is empty. If that's the case, make both front and rear 0. This is the only case that you have to change front, right? Otherwise, we have to increment the rear. So this is what we did in the linear array implementation. We just had rear plus plus. But in the case that we get to the end of the array, right, we have to start over, right? So we have to write rear plus 1 mod n. Rear is equal to rear plus 1 mod n, and then we insert the element. Similarly, for the dequeue part, we just have to make sure that the array is not empty, right? If front is not equal to -1, if front and rear are the same, like have the same index, what that means, it means that we only have one element left in the queue, right? And if we dequeue that one, we have to change both front and rear to -1 so that we know that the queue is going to be empty. Otherwise, we just have to increment the front. But again, we saw that, excuse me, in the circular array implementation, in order to wrap around, like we have to say front is equal to front plus 1 mod n. We saw that in the pseudocode implementation on the whiteboard that we just did. If you want to return the front, just like check that the queue is not empty, otherwise return the a front. And this shows like the concept of circular array and like how the enqueuing works and like how the mod operation works and so on. How do we check if the queue is empty? This is like how we can do it. Again, I mentioned that if we implement this right, we just like need to check if front is equal -1. To return the front, this is the implementation. Just check that the queue is not empty. Otherwise, you would like throw an exception. Here, like we have a return type, so we throw an exception. This compares the implementation of linear array implementation of queue and the circular array implementation of queue. You see that like they're pretty similar. The only parts that are different is this part and this part, right? So in order to wrap around the array, so we just had to like change this condition, and we had to change the rear plus plus to rear plus 1 mod size, so that when we get to the end of the array, we start from the start of the array. Similar comparison between dequeue function in the linear implementation and circular implementation. The only difference is this part, right? You see that? And this is one thing that I asked you to do in when I like was explaining things in the on the whiteboard. So if you want to display all the numbers in the queue in the circular implementation, you have to be careful. We might have a case that front is before the rear. We might have the case that front is after the rear. So you have to consider both cases. So I don't want to explain this part. I want you to practice this one yourself first. In the linear implementation, it was pretty straightforward. Front was always before the rear, so you just like had to write a loop from the front to the rear and print all the elements. But in the circular implementation, you have to consider both cases. So try to implement the display queue yourself, and then again, as a practice question, try to encapsulate everything that we covered into a template class. In the linked list implementation, as we just saw, we would have 2 pointers, the front pointer and the back pointer. So like the back pointer is needed so that we can enqueue very fast in a constant time. So we don't want to traverse through the linked list. This shows the like how the insertion and removal, again, insertion or enqueuing or pushing, removal or dequeuing or popping. Like this shows like how this works and like how the front and back pointers change values and how the enqueue and dequeue works. We dequeue from the head of the linked list and enqueue from the tail of the linked list, so that like we can just like have the big O notation one, the constant time consumption for both insertion and removal. This is the implementation of the enqueue function. Again, we saw that the front and rear are 2 pointers that we initialize them as null, right? we allocate, if in the enqueue increment, in the enqueue operation we allocated a new node, we initialize the data and next part of it, the pointer part of it. In the enqueue part, here like we don't have to check if the queue is full, because here like we don't have that concept, like we allocate nodes as we need. The only part that might cause us trouble would be like if we don't have enough memory. So like if that's the case, the compiler would throw, or the standard template exception class would throw a bad allocation exception. Similar to the array implementation, if our linked list is empty and we want to insert the first element, we have to change both front and rear. This is the only case that the front pointer also needs to be changed when we enqueue. It's not going to be pointing to nothing anymore. It's going to be pointing to the node that we just enqueued. Otherwise, we just like have to make rear point to the newly allocated node, and just like change the rear of the linked list. We covered that in the pseudocode. The dequeue part, similar. So we just have to make sure that our linked list is not empty. If it is empty, just like write a message, throw exception, return. We check if front and rear are the same. If that's the case, this is the last element in the queue, so we have to change both front and rear. Otherwise, we only need to change the front, right? Basically, like make front point to the next node. Okay, and in order to not have memory leak, we have to delete the node that we just passed, right? That's why we need to have a temporary pointer. This is showing you the concept again, front and rear, and like how like we use like a temporary pointer to allocate new nodes, and also like to deallocate the nodes that we don't need in the dequeue operation. The only changes that we have to make to our code to make this a circular linked list, right? In a circular linked list, at the tail of the linked list, this pointer is not going to be null pointer anymore. It's going to be pointing to the head of the linked list, right? So we would have like a tail pointer and a head pointer, or like front and back or rear. So then this pointer is going to be going back, is going to be pointing to the beginning of the linked list. So the only changes that we have to make to the enqueue function would be making sure that the rear arrow next points to the front, right? And the same thing for the dequeue operation, rear arrow next is equal to front. This is showing you the display function and the front function. So like here, like I'm showing you like how we can display all the nodes in the linked list. The last thing I wanted to mention, that is like the standard template library in C++ has a class implementation of queue. So it would have like some member functions similar to what we saw. Push and pop are the functions for enqueuing and dequeuing, or insertion and removal. One thing that I should mention, and I forgot to mention in the stack video as well, that in these standard template library classes, queue and stack, both of them, the pop wouldn't return anything. It's a void function. If you wanna see the like if you want to return what's in the front of the queue, you have the front function, right? The reason that this is the case is because In the exceptional cases, if the pop function wants to return something, the exception that's going to be thrown is going to cause trouble. So both push and pop are void functions. We would just like do insertion and removal of the data by changing either the front and back variables or like the front and back pointers. And if you want to see the front of the queue or back of the queue, you would have like separate member functions. This was the case for the stack class as well. That's it. Thank you so much. Have a nice day.